In today's episode of No Blocks November, we're building a Python-powered kitchen thermometer. You probably have one like this lying around your kitchen, and as it turns out, the thermistor inside of this little guy is just like the one that's in your Jumpstart or Explorer kit. So if you've been through the Jumpstart Python curriculum, you already know how to write some code to read this thing. These little thermometers may not look like much, but they're running some pretty cool code inside, and they're doing some pretty neat math as well. Check out our blog for details on how this calibration works. We show you how to calibrate it using the microbit, and there's links there that'll let you go a little bit deeper into the math to understand what's going on. So let's take a look in CodeSpace. So in the first section, after we import the microbit and math packages, we've got calibration constants. These are temperatures measured in Celsius and then raw A to D values that the microbit reported. You see we define the Kelvin conversion offset. And then there's the Steinhart-Hart equation calibration section. So that shows how the calibration constants are calculated, and that gives us our three coefficients. And then we've got a function to calculate the temperature based on a resistance, a function to use the internal pull-up resistor value to get a resistance value based on your A to D reading. And then we calculate those resistance constants based on the A to D values that we've calibrated to. Then we run the calibration, enable the pull-up, and get into our infinite while loop, reading an analog value, converting it to a resistance, calculating a temperature in Celsius, rounding it, and displaying it. And that's it. Take a look at the blog post for more details, and happy coding.